Hello everybody, how you doing? I'm Clint Bigelow. I'm not having a demo at this point. I'm just a little bit of output of where I'm at. I'm getting ready for a demo on electric generator. 220 90 amp on a standard stator. I have high output stator, so I can go significantly higher to up to a 200 amp box. I'm trying to get a sense of that. We're looking at frictionless technology at this point, because that's really the foundation of this entire demo. When I get to that point, we've really put it together. We've run it a number of times. We're getting data off of it, so that's a good thing. The machining I had done, the hub was not centered on the wheel, so it's kind of herky-jerky, so I'm not calling this a demo by any stretch. I'm going to go, we've redesigned it. We're going to have one shaft. We're going to have a weight attached to the shaft. So there's going to be, we're going to have it machined at that point with the shaft. It's going to be machined, so you've got zero deviance from this side all the way over, and that's a game changer. We're going to centrifugally machine all the components. Okay, we're going to have one shaft. I'm trying to get you to visualize it. This is not the demo, the end product. We're shifting gears where we're headed. We're going to get a hub that attaches to the shaft, so there can be no wobble at all, and that's going to take the place of this wobbling hub. So there's been many gains in technologies attempting this demo. We're backing up, we're redoing it. I've had a lot of engineers look at it. We've looked at the bearing technologies. There's quite a few advancements there I'm not going to talk about right now. We're going to talk about as I do demos for my friends. Okay, frictionless, really, you take your pinky finger to turn it. Okay, let's turn it with our pinky finger. If you can kind of see this turning. Okay, the big hub is turning much slower than the generator. You need 2,000 RPM. So what we really end up doing, we get the big hub turning, and at 650 RPM, you've got over 100 amps that shoots off to your power box. You've got a breaker on there, a 20 amp breaker that comes two hot legs come to your 220, your motor, and that takes 9.9 amps to power this motor. And it's already, this hub goes to a hub on a shaft. There again, you're gonna have to visualize it, and it turns it, and you're recycling automatically, fuelless, frictionless. So that is the theory overall. Now, what and a lot of engineering friends are pretty much into, and there again, I got to feel this out as we get along. What you need to do is spin this, there again, one finger, see, left hand, no problem to spin it. Now, we're going to get a drill motor. We're going to get this to spin it, and I'm trying to get data how long it takes to get this up. A woman could start this generator. The end goal is a woman could very, very simply start the generator. Now, we've already seen that to be true, so I think as we go, it's going to get better and better. You need to turn it. We're turning it right now. I can turn it with a big wheel, or I can turn it with a drill motor, a handheld with a battery pack. This is a 3/8 Ryobi. It's not a real big drill, but I think we're finding it to be far more than efficient. And I want common tools for everything I've got to be able to work on it. Common parts, you can really get them readily accessible in a lot of places. And that's kind of where we're at. We don't do any special tools whatsoever. We do common tools. Okay, let's spin it with a drill to get a sense of it. All right, I can spin it with my hand here. All right, here we go. All right. All right, let's get a sense. Carolyn, kind of count how many seconds you think it's taking me to get this drill to get it up to speed. Okay, you ready? Ready? All right, this is many times faster than I need to. This big hub is turning that small hub. At 650, I've got over 100 amps being shot to your panel. You got 20 amp circuit coming to your 9.9 amp 220 volt motor. As we spin it up, we got to have speed of spinning motion. Now, coming in back to your generator, I've got a 12 volt input system. I'm going to show them here. I've got a positive wire hook going in and a negative wire coming out back to the battery. We would hook this up with a switch on it. Just a little 7 amp battery. You can use 3 volt. You can use a very small battery. The point is a power source to excite the magnetic system. And that's a game changer to have such a small input. You can take that 3 volt, stick it in your pocket, run up the side of a mountain. You got more than enough power to get your generator running. Just go ahead and turn it. Hit your 3 volt power. You can bring it up. This thing will come online automatically. And go ahead and supply itself and go ahead into recycle mode. It'll do that automatically. Okay. I'm not showing the switch here yet, but after I get it spun up, we're going to hit the switch. Power the magnetic system inside the generator. As soon as you do that, you're going to have at least at 650 RPM. You're going to have at least 100 amp shot to your box. 9.9 is going to be immediately used to go ahead and turn. So what I'm basically trying to tell you, that when you get it spinning at 650 RPM and you hit that switch, a nanosecond later, this thing is automatically taken off. It's out of your control. The motor is 1725 RPM motor with a big pulley coming to the shaft pulley, which is a lot smaller. You're trying to gear ratio it off via pulleys, simple components. Here we go. Let's go ahead and let you have a look at that. This motor has a pretty good sized pulley because it's 1725 RPM. So on the shaft, you're going to have smaller, probably about 3.5, 4-inch tops, a pulley, a smaller pulley. So you get your speed that you're really looking for worked out. Okay. All right. Once we spin it up, we're going to reach over here. We're going to have a switch. We're going to hit it. And this thing is automatically going to be on its own. And that is the versatility and the game changer. Here you go. Okay, we've got 2 different power sources on the generator. I've got 12 volt input, positive going in, negative coming to my battery, DC 7 amp hour battery. I've got your main line. I have a high amp stator. There again, I'm trying to set up for, we're trying to really get set up so we can go to a 200 amp box. You can see that body is separated there. It's quite large. You see all that copper in there? The bottom line, there's a whole lot of copper in there, and when it spins, it induces a voltage. The 3 coils, that copper comes out. You've got main line coming out. With a high amp stator, we're trying to get over 150 amps. So I've got 2 big bars here. See the wires? We're going to the box. I've got a 200 amp box. I've got some students we play with that. So it's pretty cool. All right, let's go ahead and spin it. See, kind of get a sense of how hard this is to get the generator going. The second you hit that switch, it's on. I mean, the nanosecond you hit it, this motor is going to take off a lot better, infinitely stronger than this little input I have here. I just wanted to know if this is going to work, and I think it's proven out nicely. Okay, let's go ahead and spin it. More than enough right there to go ahead and hit a switch. More than enough speed. Understanding a big pulley to a small one to go ahead and get enough amperage. It's slowing down now, and just for your edification, we could have already hit the switch, it would have took off. I'm going to hit it a lot faster than that with this little bitty drill motor to prove that it will go full speed. The drill is not under a load right now. You can hear it. It's not overloaded. And there again, you can see the wheel is turning, developed in the retained energy to turn in motion. It's not under a load. It's not overheating. You can do this for hours. All right, let's go ahead and speed it up. I'm going to take it much faster than you need to take it. Carolyn, can you come over here and show that? Or does it show it pretty good?
Yeah.
Okay. All right, I'm taking it to full speed. Why? Because I'm the inventor. Much faster than you need, but to really understand, the drill motor will take it full speed and it's really not overloaded. And that's really what I'm trying to get you to understand. Very simple to get this thing up to full speed. If you had hit the switch already, it's already pretty much full speed anyway. You hit the switch, it's going to take off. It's going to go from excite your magnetic field with 12 volt. You're going to get an output, induce 3 coils, the voltage to your main line, your power box here, 200 amp cables, goes to the power box, goes to your breaker, 20 amp breaker. Two hot lines come in. If you could come over here, Carolyn, we'll go ahead and show the motor. I hope we can see it good enough. Okay, all right. We have color-coded wires. I have a wiring diagram that comes with the motors. So I've had students wire these 220 volt motors in like 10 minutes, no problem, because they're color-coded in the schematics. So it's really an average person can get a motor and go ahead and wire these because they're color-coded. And it shows here I can either use 115 or 230, which I'm using 220, which is fine. I prefer 220. You can use 115. There again, my generator outputs 220. I'm kind of sticking there at 12 volt, so I'm kind of happy with 220. All right, let's go ahead and look at an alternator turn generator. Let's come on in here and take a look. All right, 12 volt literally shoots in. You've got brushes. It's coming in right here. If you can see that copper right there, 12 volt, one's positive, one's negative. It puts it on that seal ring, the positive. It goes through. Let me see if I can. I'm not going to pull it all the way off. Goes through your wires, comes back to your negative, and that's it. That's your 12 volt input. It just shoots it in through wires and comes back. Now, this is iron material, a special iron. That 12 volt shooting through causes positive and alternating positive and negative fields. That positive and negative fields that it's creating, it's pulsing electricity, and it's a rotating with the that magnetic system is rotating. So you can see that rotor rotating. So that 12 volt is getting in there, going through, it's going positive and negative, it's alternating, it's pulsing electricity, and 218,000 feet per second. I have no idea how many times a second, it's a whole lot, but it's a pulsing issue. You've got iron here. That iron reacts to the stator. Here's a stator. Okay, they're in close proximity. When you put them together, that iron is pulsing, and you have iron in the stator with copper in the stator. When you get a quantum fluctuation derived from that iron, this, and the pulsating and all that really comes together, it induces an output on the generator via these copper wires that are literally 3 coils, comes together in wires, 3 wires, and shoots it to your house. Unbelievably simple system that never touches. These stators can be literally 100 years old and work just fine, and that's a game changer. You really can't have a problem with if they're not touching or they're not grounding. I've got rotors, 20, 30, 40, toward 50 years old. All you're really doing is you have brushes, put positive in, negative on the other copper. and that's it. It's a very, very, very simple system with no touching components. Rotors are dynamically balanced. All right, look how easy that turns. And you get a sense of a dynamically balanced electrical component. That spinning magnetic field is part of the secret. Being dynamically balanced is part of it. The north and south fields that are created with a pulsing magnetic system is a part of it. I told you, as soon as we speed it up, we hit that 12 volt input. It comes in here. It creates that pulsing electricity, and that's it. It goes. You've got, as soon as it creates that, literally from the atmosphere itself, electricity is pulled onto your surrounding stator in 3 coils. The electricity is induced and shot into your house. It's the world's simplest generator, the world's easiest to figure out, the world's easiest to rebuild. There's very few wearing components. A spinning field, no magnetic drag effect off of that spinning magnetic field. It induces electricity onto this stator, which means you have no AC drag effect. AC generators have a big drag effect on AC. That's a problem, and it limits their output. Normal AC generators have an output of 4-pin 30 amp. I'm looking at with a heavy stator, I can really change the generator output as needed. The bigger stator, we can start at a much higher level than 220, 90 amp. We can start in the hundreds, and I can modify the generator output with power mods. So I'm turning an alternator into a generator with power mods. I'm not going to fully discuss it tonight. There again, I'm going to really do demos and talk to some people about it. I think at that point you'll really appreciate it. But the dependability of these generators is pretty incredible. I've taken all the 12 volt off of this, and you kind of figure out the output I'm looking for. A small stator for like 90 amp. A lot of people are looking at RVers are looking for that. Maybe you want to put it on a lawnmower, who knows? You can go so many directions. So, and I think it's going to go in a lot of directions. You can put a high output stator on. You can really juice it up. There's power mods we can work with to get you to 200 amp. So many capabilities, and that's the thing. The power company gives you one option. That's it. No, I give you whatever you want, and you've got engineers that tweak it out for you. That is a generator. Basically, what it'll do. Basically, that's it. Generator is so simple. 12 volt. It induces 3 coils in output. Spin it with your fingers, your pinky finger, no problem. We spun it with a drill. I've got a 3/8 drill, not a real strong one. It'll take it to full speed. I wanted to test it and really show you. I've got students doing it. Women can do it, no problem. Get it up to speed, hit a switch, it takes off automatically. You got 200 amp power, and it's dependable. Now, alternators in deserts have not been known to fail when you're using them for 12 volt output, and that's sitting on top of a 200-degree motor. What if you weren't sitting on the top of a 200-degree motor and you didn't have that heat jumping all in them, induced right in that metal, all that heat? Well, if you're not having a problem to start with, you kind of see where I'm headed. It's almost impossible to get these things to overheat. Over 200 degrees. It's not going to happen. So you take them off that motor and you pull all the 12 volt electricity that's really holding this thing down. You're amazed because it just won't overheat. It won't overheat on a car. Pull the 12 volt system off. It's a load that I don't like it. As soon as you do that, it's a real game changer. And that's it. All right. Got to say one thing. Roll Tide. You knew it. Thank you.